students, I myself is Dr. Rajshekar Reddy, Assistant Professor of Mathematics, Government First Grade College, Pavagada. Now we discuss third semester BCA Mathematics. So in this we go for Unit 1 matrices. In the previous sessions already we have learned about basics in matrices, types of matrices, determinant of a matrix, how to find the determinant of a given square matrix. Then we discussed how to find the adjoint of the given square matrix. Whenever you know that determinant and adjoint of a given matrix, then we can find the inverse of a matrix. How can we define the inverse of a matrix? Suppose A and B are two non-singular matrices of same order such that AB is equals to BA, that is equals to I. Then the matrix B is called inverse of A, is denoted by A inverse is equals to B. Hence AB is equals to BA is equals to I. Then A into A inverse is equals to B into B inverse is equals to I. Based on this, we can say that A inverse is equals to adjoint of A divided by determinant of A. So while defining the inverse of a matrix, given two matrices should be, or given matrix should be a non-singular matrix. Non-singular means whose determinant is non-zero. Given matrix is a non-singular matrix only. For that only we find its inverse. So to find out the A inverse is nothing but adjoint matrix divided by its determinant. So the properties of this inverse matrix is the inverse of any matrix, the inverse of a matrix exists only when such matrix is non-singular. Whenever the given matrix is non-singular, the inverse only exists. Suppose A is singular, singular means its determinant is 0. In this case, A inverse does not exist. Suppose A and B are two non-singular matrices of same order, then AB whole inverse is equals to B inverse into A inverse. Okay? Have you understand about inverse of a matrix? So inverse of a matrix, to measure the inverse of a square matrix, first that matrix should be a non-singular matrix. Non-singular is nothing but determinant is non-zero. So to measure the A inverse is adjoint of A divided by its determinant, adjoint of A divided by det A. So determinant of A into A inverse is nothing but, already you know the formula for A inverse is nothing but adjoint matrix divided by determinant matrix, cross multiplication. If you take determinant of A into A inverse is nothing but adjoint matrix. If the given matrix A is singular, then A inverse does not exist. Okay. A is non-singular only, A inverse exists. If A is singular, A inverse does not exist. If the matrix A is non-singular, then only A inverse exists and contains same order. A is a matrix of order 3 by 3, its inverse also a matrix of order 3 by 3. AB whole inverse is nothing but B inverse into A inverse. For one problem we find the inverse of the matrix. To find out the inverse of any matrix, first we have to calculate its determinant and adjoint matrix. To find out the inverse of any matrix, first we measure the determinant and its adjoint matrix. For this matrix A containing 2 rows and 2 columns. For first row 1, 8, second row minus 6, minus 4. For first row, first element 1 is there, second element 8, third element minus 6, fourth element in second row this element is minus 6 and second element is minus 4. First we measure the determinant of A. Already we learnt about the determinants of the matrices in previous sessions. That's why here we can get the determinant of A is equals to 1 into minus 4, 1 into minus 4, formula default minus 6 into 8. So minus 4 minus 6 8 ja minus 48, minus 4 minus into minus becomes plus 48. So minus 4 plus 48 is equals to 44. Next we measure after getting the determinant of A matrix. Next we discuss about adjoint matrix. Already in the previous session we discussed how to measure the adjoint matrix. To measure the adjoint matrix, first we have to calculate minors, then cofactors. After that, transpose of the cofactor matrix is nothing but adjoint matrix. So now we measure the minors of these elements. The minor of 1 is eliminating this one row and the column containing this one. So eliminating these two, row and column, we get minus 4. So minus 4 is the minor of 1. Like that, the minor of 8 is eliminating this row and this column. Minor of this 8 is minus 6. Next, the minor of minus 6 is eliminating this row and this column is 8. The minor of minus 4, the minor of the minus 4 is eliminating this row and this column is 1. After getting all these minors, we have to write cofactors. Cofactor of 1 is, to measure the cofactors, the minors we multiplied by minus 1 whole to the power of I plus z. The element 1 lies first row, first column. That's why minus 1 whole to the power of 1 plus 1 into its minor is minus 4. Minus 1 whole square into minus 4 is minus 1 whole square into minus 4 is minus 4. Next we measure the cofactor of 8. This 8 lies in first row, second column. That's why minus 1 whole to the power of 1 plus 2 into its minor is minus 6. So minus 1 whole cube into minus 6. That's why minus of minus 6 becomes plus 6. Next, minor of minus 6. Minor of minus 6 is, this minus 6 lies second row, first column. That's why minus 1 whole to the power of 2 plus 1 into its minor 8. Minus 1 whole cube into 8 becomes minus 8. Next, the minor of minus 4. Sorry, not minor, the cofactor of minus 4. The cofactor of minus 4 is, so this minus 4 lies second row, second column. That's why minus 1 whole to the power of 2 plus 2 into its minor is 1. So minus 1 whole power 4 into 1 becomes 1. So after getting all cofactors, we write the cofactor matrix. The cofactor matrix is minus 4, 6, minus 8, 1. The transpose of this cofactor matrix. The transpose of the cofactor matrix is adjoint matrix. Such adjoint matrix of the matrix A is minus 4, minus 8, 6, 1. For any matrix, it should be a non-singular matrix. For non-singular matrix, to measure inverse matrix, first we measure its determinant and adjoint matrix. After getting these two, we can write A inverse. Then A inverse is equals to adjoint matrix divided by determinant. That's why A inverse is equals to 1 divided by 44. 44 is nothing but determinant. 1 by 44 into adjoint matrix, that is minus 4, minus 8, 6, 1. Like this, we measure the inverse of the given matrices.